So molar mass. Mass and the mole. The definition of the mole pertains to relative atomic mass. Okay, as we mentioned earlier in the course, okay, we talked about how everything is compared to one atom of carbon-12, which has an atomic mass of 12 units. Okay? So 1 mole of carbon-12 atoms, okay, so 1 mole contains 6.02 times 10 to the power of 23 atoms of carbon-12. Okay? And that has a mass of exactly 12 grams. So that's what we're going to the assumption that we're going to compare it to. So we look at the atomic units, atomic mass units, and we're going to compare it to grams for every single 1 mole. Okay. So the Avogadro constant is the factor that converts the relative mass of individual atoms or molecules expressed in atomic mass units to mole quantities, which are expressed in grams. So what we're going to be looking at is, well, whatever the atomic mass units are of an atom, we're going to compare it, and it compares the U units, and we're going to use it with regards to grams. And what we're going to do ultimately is we're going to look at it in terms of how many grams in 1 mole of that atom. Okay, so that's going to be where the comparison is going to lie. Okay. So what is molar mass? The mass of 1 mole of any element expressed in grams is numerically equivalent to the average atomic mass of the element expressed in atomic mass units. That's just what I just wrote here. Okay, so for whatever the atomic mass is, we're going to make it equal to that, but instead of using the AMU units or U units, we're going to say grams. Okay, so let's look at it in this table. So we have hydrogen. What is the atomic, the average atomic mass? 1.01, right? So 1.01 U. But if we're looking at it in terms of molar mass in grams, we're going to just remove this U and write in 1.01 grams. Okay? So in 1 mole of hydrogen, we're going to have 1.01 grams. So 1.01 grams of hydrogen in every 1 mole of hydrogen. Oxygen has an average atomic mass of 16.00 U, so it's equal to 16.00 grams. Okay. Sodium, 22.99 atomic mass units, so 22.99 grams. Okay, we're looking at calculations. Remember, guys, significant digits. Don't forget that. Okay, last one here in this example. Argon, 39.95 atomic units. And we're going to translate it to 39.95 grams. Okay, so far pretty easy, right? It's not that hard. So, the mass of mole of substance is called the molar mass, and we're going to use the capital M. Okay, molar mass. Molar mass, always remember this. Molar mass, think of moles, mass, what units come to mind? I'm going to think of grams. So, molar mass is always expressed in grams per mole. Right? So think of it this way. Grams per mole is grams over mole. When we're looking at it as grams per mole, we're looking at it grams per 1 mole, but we never write the 1 mole. Right? It's just like, think of units like kilometers per hour. Right? The speed per 1 hour. But we don't put that 1. Okay? Same thing here. So grams per mole means grams per 1 mole of that. Okay. So, here in this example, the average atomic mass of gold is 196.97 units. Therefore, the mass of 1 mole of gold atoms is 1.96.97 grams per 1 mole. If we're looking at it, so the molar mass Okay, the molar mass is that. The mass of it is just, where is that? That. If we're looking at it in terms of 1 mole. Okay. If we're looking at it in terms of 2 moles, what do you think you're going to do to that number? Multiply by 2. Okay. So if you were trying to find the mass of water, you'd want to find exactly. So you'd have 2 hydrogens. You find the atomic mass units and use them as grams, and then the 1 mass of oxygen, and then add them all together to find the weight of 1 mole of water. Okay, finding the molar mass of a compound. Find the molar mass of beryllium oxide. To do this, you must be able to identify its chemical formula. Okay, this is what I said. Okay, you have to be able to put together the formula. If I give you the question, find the molar mass of beryllium oxide. If you cannot do that, there go the marks. So your ability to name, okay, and write the formulas must be top-notch at this point. Okay. So 1 mole of beryllium oxide contains 1 mole of beryllium and 1 mole of oxygen. So, if we look at the periodic table, okay, and I don't think the example is there. Okay. So if we look at the periodic table, what is the molar mass of beryllium? 9.01. And what do we use in terms of? Now it's grams, right? Grams per mole. Grams per mole. What is the molar mass of oxygen? 16.00 grams per mole. Okay. So what is the molar mass of this entire this formula of beryllium oxide? You add them, and so we get, what is it? 25.01 grams per mole. Okay. But least number of significant digits, well, we don't have it in the question, so pretty much just keep those numbers. Okay, there's no number in this question. So I'll allow you to just keep all those. I'll allow you to round off to that if you wanted to. Okay, but always try to keep 1 decimal place, 2 decimal places if you are not given any numbers to use to calculate your significant digits. Okay? First question. Determine the molar mass of ammonium phosphate. Here we go again. I don't give you the formula. You must be able to put together this formula. And one common thing, and I hope you're not doing this right now, I hope you're not looking through the periodic table for ammonium. You will not find ammonium in your periodic table. Because ammonium is one of the polyatomics that you've been asked to memorize. Okay, so we need to determine the formula of the compound, then use the periodic table to add up the individual molar masses. So, here's the formula. NH4, 3, PO4. So you must be able to put this together, this formula. Okay. So let's break this down into each one of the atoms or elements that we have. We have nitrogen. How many nitrogens? How many nitrogens? 3 nitrogens. How many hydrogens? 12. How many phosphorus? 1. And how many oxygen? 4. Okay. So, what am I looking for right now? The atomic mass, right? And we're going to compare that, we're going to convert that AMU units to grams per mole. Okay. And we're going to do like we did with beryllium. The only thing is what is the atomic mass of nitrogen? or what is the molar mass? Let's use that terminology. What is the molar mass now of nitrogen? So 12.01. 01 what?
No,
Is that, are we on the right one? 14. 14.01, and it's grams per mole. But how many nitrogens do we have? 3. So what do we got to do with that number? Multiply by 3. Okay. How about hydrogen? What is the molar mass of hydrogen? 1.01 grams per mole. And what do we got to do with that? Multiply that one by 12. How about phosphorus here? What is the atomic mass? 30.97, and it's grams per mole, and we're multiplying it by 1. Right? And oxygen, 16.00 grams per mole, and we're multiplying that by 4. Okay, so here we have those molar masses, and I've decided to round them off to the nearest whole number. Okay, because again, we can do that. There are no numbers in our question, so we can just use. Okay, we can just use the numbers. But if you did, by all means, please do. Okay. Like I said, we want to try to keep things to at least 1 decimal place, 2 decimal places, if if our question does not give us. So then we put the formula in. We multiplied. Okay, so this one. So we have nitrogen here. There are 3 nitrogens multiplied by the molar mass, or the atomic mass of the of nitrogen. We have 12 hydrogens. Okay, so this was just for hydrogen. Okay, this one is for phosphorus. So we have 1 phosphorus, and we're multiplying it by the grams per mole. And we have 4 oxygens, and we multiply it by its molar mass. And once we find all 4 of these numbers, okay, we add them all up, and we get, calculate the mass of 0.25 moles of potassium oxide. Okay, so now things are a little bit different here. I'm giving you the moles. What were the mass before based on? It was based on 1 mole. Now we're looking at a quarter of a mole. Okay, 0.25 moles. So there are a few changes to the formula. We know that molar mass is equal to the mass divided by, the mass divided by the number of moles. Sorry. Okay. So, let's do that. Mass. There we go. Okay. Molar mass. Yeah, it was so confusing because it was all M's. Okay. Molar mass is equal to mass over the number of moles. Okay. But now, we know that. Right? What is the question asking us for? Quarter of a mole. But the mass. So which means it's asking us to find that. Are we given moles? Are we given moles?
Yeah.
Yes. Right? That's that one right there. How about molar mass? I can find that out, right? I can find that out. But what do I need to do before that? Figure out my formula. I have potassium oxide. How many of each atom do I have? So I must be able to put together that formula. So potassium. So what kind of compound is that? Potassium oxide. Ionic. So metal, non-metal. So we go through the 5-step crossover rule. Potassium. What is the formula? Or the symbol? K. How about oxygen? O, right? What's the charge for potassium? +1. Oxygen? -2. So then all we got to do, cross them over. What's our formula? K2O. Okay, so here is what we use this pyramid here to show that. Okay, so remember the pyramids that we were using in physics? Got a pyramid here for mass. So now let's label this. M, molar mass. M, the mass. N, the number of moles. Okay. So which one do we need to find? The mass. So how do we use the pyramid? Who remembers the way I use it? You cover up which one? The one we need. Which one of these do we need? The mass. So we cover up the M. So we cover up this, or just blank it out, and we have molar mass side by side with the number of moles. So we're going to multiply that. Good. Or times it. Multiply it. Okay. So if we need to find the mass, we remove the mass from the triangle. Okay. So I just removed it. Okay. And we're multiplying the molar mass with the number of moles. Okay. And again, we need to find the molar mass. Okay. So here's the molar mass of potassium oxide. So you can double check it yourself. So we have one atom. Sorry, we have two atoms. We have K2O. So we have two atoms of potassium, and we have one of oxygen. So you want to find the molar mass of two potassium atoms and one oxygen atom in this molecular formula. And we get 94.2 grams per mole. And we're going to multiply that by 0.25 moles, right? So we're left with our molar mass times our that. But now, what units are canceling out in this question? What units are canceling out? Moles. So moles are canceling out. So my answer is going to be in grams. So when I multiply those two, I get 23.55 grams of K2O, potassium oxide. So it's really important that you are able to write that formula, because like I said, if you made the mistake in the formula and you did that somehow, or just KO, you're losing out on a complete molar mass of potassium. Okay. And in this one, yeah, the same thing. You're losing out on one molar mass of potassium, and you're adding in the molar mass of oxygen, an extra one. Okay, so that's why it's really important. I can't stress enough how important your ability to name is. Determine the number of moles found in 17.35 grams of cuprous nitrite. The mass, okay, the mass of cuprous nitrite, 17.35 grams. We said that in the formula that we needed to find. Okay, so we had molar mass. Okay, we had mass and we had number of moles. So we know we have this one. We can calculate this one, which means this is what we're trying to find. Okay, so cuprous nitrite, CuNO2. Did you get that? Good. Yeah. Okay, because at least if you got that, you know you're at least on the right track. Because how many coppers do we have here? One. How many nitrogen? One. How many oxygen? Here was really important to figure that out. And if you messed up on which cuprous we had, right? If you put the 2, so if you put one of the other ones, then you would have messed up the answer. So the molar mass, I hope you got this, 109.5 grams per mole. Okay. So we had 1 copper, 1 nitrogen, and 2 oxygen. So what we did was we multiplied each one by their atomic mass, okay, to get the molar mass. Okay, so from this, what are we covering up? The N. We're covering up the N, and we have the mass on top of the molar mass. So what function are we doing? We're doing division between these two, right? Because the N is on top of the molar mass. So we get the following: 17.35 grams divided by 109.5 grams per mole. What cancel out? Grams. So our answer will be in moles. What's the least number of significant digits in my question? There are 4, right? It's the only number that I have. So my answer must have 4 significant digits. So we've got the following 0.158. Okay. But that's how many significant digits? 3. Right? And so actually if we got that...
I got 1584.
1584? Okay. 0.1584 moles of cuprous nitrite. So ignore that. Pardon? No, you couldn't put U. Yeah, because that's based on atomic mass, the average atomic mass. Okay. So you got 0.1583, right? Is that what you said? Oh no, that's, well, it would have been based on your calculations, depending on...
It's 5836, so just round 6 to 4.
No, there's like 1587, isn't it?
Was it?
And I just rounded.
Okay, so I'm relying on you guys to do the calculations.
But would it matter? Like,
Well, no, it wouldn't matter, because if you left this, right, 1 point, you rounded that incorrectly. Because the number that you're dropping, right, is a 5 or greater. And in fact, we are actually closer to that than we are to the 3. So that's why it would be, you'd lose a mark for that. You'd lose a mark for that. But you get, you get those marks. Determine the molar mass of 0.75 moles of an unknown solid crystal if the mass was 43.875 grams. We look at this question, right? Remember what I just said? Molar mass, right? Here's moles, here's mass of it. And molar mass is always written in grams per mole. So all we're doing is we're taking the mass, 43.875 grams, and we're dividing it by 0.75 moles. And what do we get? You sure? Every time I type something out, I gotta do the calculation here on my own. 58.5. Good.
That's nickel, right? Or would it be?
58.5 grams per mole. What's the least number of significant digits in my question? 2. So my answer must be rounded down to 59 grams per mole. Determine the mass of 2.35 moles of sodium acetate. We know we have the number of moles, which is 2.35. Okay. We have 2.35 moles of sodium acetate. Sodium acetate, there's the formula, NaCH3COO. Okay. So, with that formula, what can I find? The molar mass. Right? So I want to find out the molar mass of each one of these atoms and add them all up. Okay, and we get the following, 82.04 grams per mole. So that's our molar mass. So according to our pyramid, what do we not want? What are we trying to find? The mass. So we're going to cover up the mass or eliminate the mass up in our pyramid. And what function are we doing between molar mass and moles? We're multiplying, right? So we're multiplying 82.04 grams per mole times 2.35 moles. What cancel out? What units? Moles. And our answer must be in grams. The answer you should have gotten 192.794 grams. But what are the least number of significant digits in my question? 3. So I want the 192. But I don't just take 192. I look at the number I have next to it. Who cares about these? These don't matter. It's only the one number that is following what we're keeping. So what does the answer become? 193 grams of sodium acetate. Find the number of moles found in 12.86 grams of plumbic thiosulfate. We have the mass of our formula, right? We are trying to find the number of moles, so we're trying to find N. So we need the formula. So the formula is as follows. Plumbic thiosulfate. There's your formula. PB, open brackets, S2O3, close brackets, 2. Here's why it's so important, because if you mess that up, there go the marks. Bye-bye, just like that. So with that formula, what can I find?
The mass.
The molar mass. Try to find the molar mass. And the molar mass, 431.6 grams per mole. We've been able to stop time and do that calculation without really skipping a beat. Okay, so we have our pyramid. What are we covering up? We're covering up the N. Right, we're covering up the N. So we have the mass on top of the molar mass. So what function? Division. So we get 12.86 grams divided by 431.6 grams per mole. What are we canceling out? What units? Grams. And our answer is going to be in moles.
That's not like that. I want 4.8.
So I got 431.46 for the mass.
431.46. Can anyone verify that?
I got 4.8. That's close, so it's close.
Okay, so how many how many lead do we have? We have one. One lead. How many sulfur? 4. How many oxygen? 6. Anyone else verify?
It's 4.8. It's still.
It's 4.8?
Yeah.
Okay.
Like 431.5.
Yeah.
Okay. So we've got a mistake here on the PowerPoint.
I'm not gonna fix it.
I'm going to call my partner and put together who gave me this PowerPoint. So, 431.48 gram, 485?
No, it's just 4.8. So like.
Okay. Grams per mole. So that's what we're going to put in here. Grams per mole. Sorry for the mess. And what do we get when we divide those two? Give me as many numbers as possible. And I'll tell you when to stop.
0.0.
Okay, so 0.0298
298.
043, that's good. And it's moles. All right? So, what is the least number of significant digits in my question? The only numbers. 4, right? 4 of them. So, this 0 does not count here. So it's all this we need. Here's the first significant digit, the 9, the 8, and this 0 is what we need. We look at this number here. Does it change it?
No.
No. Do I keep this 0?
Yeah.
Yes, I do. So I get 0.02980 moles, okay, of plumbic. Oops. Paving S2O32. Okay, of plumbic thiosulfate. Sorry about that little mishap there. But I'm glad that you guys caught it and we didn't keep going. How many times I've made a mistake on the PowerPoint and everyone just keeps going with it. 2 times 2 is equal to 5 and no one's saying a thing. We keep going.